Hey guys, today let's solve the flip equivalent binary tree. So this is the given problem, right? They are giving us two roots, which is root 1 and root 2. What we need to do is to check if the given binary tree is flip equivalent. Well, what does it mean? Let's take a look at the example 1. Is it flip equivalent? Yes, right? They are flipping on the 1, 3, and 5. So this is flip equivalent, right? We return true. What if the given input is empty list? We will just simply return true. What if one of them is null? We will return false. Let's take a look at the example 4. Let's say the given input is 426, 462. So the output will be true, right? Because we are flipping on the node 4. Main thing is that the node is unique, right? And the problem is asking us to check if the given root is flip equivalent. That means we need to check for flipping nodes and non-flipping, right? Then another thing is that if the value is not equal, we need to return false. Then how we can solve it? Well, basically to solve the binary tree problem, you can use DFS recursion or DFS iteration, or we can just simply use BFS, right? I will show you 3 of these options and walk through the diagram. So for the DFS recursion, first we need to check if the given roots is null, or if both of them is null, return true. If one of them is null, or the value are not equal, return false. Then recursively check the flipping and non-flipping nodes. Let's say the given input is like this. So it will be called flipping equivalent root 1 dot left, root 2 dot right, and flipping equivalent root 1 dot right and root 2 dot left. Flipping nodes. So we're gonna check the non-flipping one, right? It will be flip equivalent root 1 dot left and root 2 dot left. Then flipping equivalent root 1 dot right and root 2 dot right. Non-flipping nodes. So on here we're gonna call flipping equivalent root 1 dot left is not 2, right? How about root 2 dot right? That is not 2 as well. Then flipping equivalent root 1 dot right is not 6, root 2 dot left is not 6 as well. That's all, right? Meanwhile on here we're gonna call flipping equivalent root 1 dot left is 2, root 2 dot left is 6, root 3 dot left 6. Flipping equivalent root 1 dot right is not 6, right? Root 2 dot right is not 2. That's all. So from here it will be return false, return false. So for flipping node it will be return false. Meanwhile for here it will be return true, return true. So for flipping nodes it will be return true. So this is true, right? Let's turn them into code. Cons flip equivalent root 1 root 2 if root 1 is null and root 2 is also null, we return true. If one of them is null or root 1 dot value is not equal to root 2 dot value, return false. Then we return flip equivalent root 1 dot left, root 2 dot right, and flip equivalent root 1 dot right and root 2 dot left. This one is for flipping notch, or non-flipping notch, right? I will just copy this. This one will be the left, and this one will be right. That's all, right? Let's do the time and space complexity analysis. This one will be all in time and all in space due to recursion using stack. This one will be same all in space due to recursion using stack. All one time, all one time. So overall for this will be all in time and all in space. That's it. So let's move to option 2, right? First, we need to click stack and push the root 1. Then push root 1 and root 2 into the stack. While stack is not empty, return true for final decision after check. Get the nodes from the stack. If both of them is null, we just continue. If one of them is null or the value is not equal, return false. Then check the flipping nodes with left right and right left. Check the non-flipping nodes with left left and right right. If it's flipping, stack push left right and right left. If it's not flipping, stack push left and left and right right. Else return false. And for here, create helper function to check if they are equal. Basically, it's similar to symmetry. Let's say the given input is like this. So first, we're gonna start from stack is 4 and 4. While stack is not empty, we get the 4 from stack, right? And because stack is last in first out, we use pop. And now the stack is empty list. We're gonna check the flipping is equal left right right left. Okay, so it will be 2 and 6 and no. The left one is 2, then how about the right one is 2 as well. Then is equal, the right one is 6, the left one is 6 as well. This one is flipping nodes. Then this will be return true. Non-flipping is equal 2 and 6, and is equal 6 and 2. Non-flipping nuts. This one is return false. So because this is flipping, right, stack will push left and right, and right left. This will be push 2 and 2, stack push 6 and 6. Now the stack we have 2 and 6. One stack is not empty. Last in first out, so we're gonna get the 6 from the stack. Stack is leave 4. Now the stack we have 2, right? So for this, because on here they doesn't have any child node, right? So we're gonna push now, and this one will be same. This one will be null as well, and null. And because both of them is null, it will be return true, right? Both of them is true. We can choose one of them. So let's say I choose the non-flipping, so it will be stack push now stack push null and null. Now the stack we have this, right? One stack is not empty. Last in first out, so we're gonna get the stack null first. Stack dot pop. Now the stack we have 2 and 2, null and null. Both of them is null, so we just continue. Now we only leave 2 on the stack, right? And because both of them is null as well, we just continue again. Now we get the 2 and 2. Now the stack is empty list, right? So it will call this again. Because 2 doesn't have any child node as well, right? So we're gonna check the flipping nodes and non-flipping one. Both of them is true, so stack will push null as well. Now the stack we only have this. It will be continue until stack is empty and return true. Let's turn them into code. Root 1 and root 2. Root 1, root 2. Oh, it will be stack.length is bigger than 0. Then if both of them is null, oh no, is equal meanwhile for the non-flipping, I will just do this. I will just copy this for here, because we're gonna check the non-flipping, right? So it will be left and left, right and right. Okay, non-flipping. If it's flipping, stack push left right and right left. As if non-flipping, this one is return false. This one is to check if they are not flipped not or non-flipping. Return to final decision after checking. Stack push left left and right right. Stack dot push p dot leave q dot right. Stack push p dot right q dot leave. So for this it will be left and this one is right. That's all, right? Let's do the time and space complexity analysis. This one is O1 time, O1 time, purpose overall is O n time. Purpose overall is O n time. I will just copy this. Okay. Meanwhile for here it will be O1 time, O in time, O in space. I think I missed the is equal. This one will be P and Q. Then if both of them is null, right? Return true. If one of them is null or the value is not equal, return false, then we just simply return true. That's all, right? For this it will be O1 time and O1 space. So for the DFS iteration, O in time and O in space. That's all. For the BFS, actually the same with DFS iteration with one stack, but the only thing that is different is that BFS are using queue, not using stack. So let's try them, right? Option 1, BFS iteration with one stack. Const is root 1 and root 2, right? Stack the length is bigger than 1. Const p Q is state.pop. If both of them is null, continue. If one of them is null, or the value is not equal, return false. Then we need to check the flipping nodes and non-flipping right is equal p.leaf q.right and is equal p.right q.leaf const non-flipping. I will just copy this. This will be left and this will be right. If they are flipping, step push left right and right leaf. Else if non-flipping, step push left and right. Else we just simply return false. Step push p.leaf q.right. Step push p.right q.leaf. I will just copy this. Const is equal p and q, right? If I think I made a mistake here. It should be bigger than 0. Let's submit. Return true. If one of them this one shall be on here. Return true. Okay, I think that is all from me. See you next time.